Dear participants, I regret the delay caused due to unavoidable circumstances at our end. Today, I am very happy to welcome and introduce today's speaker, Dr. P. Mohana, Madam. She is working as a scientist at the Center for Remote Sensing and Geoinformatics, Chennai, Tamil Nadu. And it is really a great pleasure that we will learn lot of things from Dr. Mona Madam. If I read the CV of ma'am, it may require couple of hours to read it, but I will try to introduce today's speaker within 2 to 3 minutes. Madam has completed her MSc in Geoinformatics, PhD in Geoinformatics, and presently she is working as a scientist. Till today, she has completed
Dapat konti.
10, 10 research projects funded by various institutions in India and abroad. She completed various value-added courses related to geoinformatics and development in the field. One patent is at the credit of Mona Madam, and it talks about the quality of the speaker. She has published various research papers in international reputed journals, and if we look at the number, it will go beyond 30. Beyond this, she has participated, I can say, actively participated in national and international level conferences. Various books are at the credit of Dr. Mona Madam. She has contributed more than 10 book chapters, and the various books which are published by the publishers in India and abroad. If we talk about her specialization, she is mostly focused in the area of geomorphology. If we look at the research papers published by Dr. Mona Madam, they are freely available at ResearchGate and Google Scholar. You will find that overall focus of the madam research focus is geomorphology and the application of geoinformatics in geomorphology. With this brief introduction, madam, I once again welcome you on this virtual platform of International Workshop on Digital Image Processing. On behalf of Department of Geography and Internal Quality Assurance Cell of ASP College Devruk and all other collaborating institutions, once again I welcome you and I request you kindly proceed ahead.
Yes,
Welcome,
sir.
ma'am.
Yes, sir. Thank you, sir. Thank you very much. Thank you very much for your brief introduction, sir. Really, it is a very nice. And thank you very much for giving this opportunity to deliver my lecture as a resource person in this international workshop. Thank you, sir. Actually, today's topic is digital image processing. In that subtopic, that is comes under the digital enhancement techniques. Actually, in the previous extension, all those sections, you have discussed about you people have learned a lot about the digital image processing. What is meant by digital image processing? How we are doing the various image processing techniques. The four major component of the digital image processing is first is the image rectification and restoration. In the rectification and restoration, you people will learn how the satellite imagery will be and what are all the rectification methods. For the example, 6-line dropout, and then noise removal, and then earth curvature problem, the various radiometric and geometric corrections, and all those things you people are learned in that image rectification, and then after the successful rectification of the various noise removal and the radiometric and the geometric corrections, we have to save that in proper imagery format, whether it will work in various softwares like ADAS, NV, or some other softwares also. So that is called as image rectification restoration. Next import of after the correction of all the image rectification methods, next important topic is image enhancement, image enhancement methodology. In that image enhancement methodology means in after correcting the various satellite imagery, we have to give the enhancement. That is, we have to that is spatial enhancement and then spectral enhancement to get the better clarity. Not only the clarity, better interpretable features depends upon our need. So that is the important thing for the image enhancement techniques. Today we are going to discuss about the image enhancement technique only. In that image enhancement, various spatial and then various spectral enhancement. You people already learned in the previous sections, the day before section, yesterday, and then yesterday's session, all those sections. But today the important content of this lecture is in that image transformation. Last method is there. That's all comes under the transforming the satellite imagery. That means after that image, that is after that image spatial enhancement and then spectral enhancement, we have to transforming the satellite imagery to get the better output from of the objects. Objects or the interpretation depends upon the user need. So in the transformation method, I am going to discuss about the ratio image. That means band ratioing or the image ratioing. How we have to do that various image ratioing to get the better outputs. Next one is the principal component analysis. One of the important methodology in that digital image processing is principal component analysis. Why it is? Because of importance for the agricultural and then forest-based studies. It will give the more and more covariance. So then only then in that case we can get the large number of interpretable features. Even though with high resolution satellite imagery, not comparative to that 1 meter or 15 meter, 10 meter, 1 meter or less than 1 meter. Even though for 22-meter resolution also in principal component analysis, if you are doing, we can able to discriminate the crop, different types of the crops, and in some places, if it is a 1 meter resolution, then we can be able to easily discriminate the phenological characteristics of the crop also. So in that part, that principal component analysis is very, very important. Next important thing is Tassel Cap. Tassel Cap method is nothing but we have to study about, if you want to go to study about the soil relevant study, soil moisture content study. So that type of the study, if you are going for the Tassel Cap enhancement technique, it will give the better results to study about that. And moreover, some of the geological studies and then geomorphological studies also, the Tassel Cap is very, very important. Next one is the change reduction. Change reduction, you people, most of them know very well that temporal changes of one satellite, changes of one particular area, or that seasonal, any seasonal temporal changes means it includes the seasonal changes or decadal changes or like that. So that type of the change reduction we can also see. So these are all the outline of the today's lecture. First one is the little brief about the image enhancement. Image enhancement, that modification of the image to alter its impact on the viewer. Impact of the viewer means if you are a agricultural person, then so it is little brief about the various enhancement to get the better interpretation, better object extraction or feature extraction method only we are going for the image enhancement. That means the process of making an imagery more interpretable for a particular applications. Depends upon the applications. So in that application means in some band combinations, you people know very well that Landsat satellite imagery and then various hyperspectral satellite imagery, that basic, that means that's and all comes under in remote sensing part. Actually for the remote sensing, we have four different segments. One is the basics of the remote sensing, next one is the digital image processing, and next one is the GIS, and next one is the GPS applications and all those things. If you know about the remote sensing, basics of the remote sensing, then only the image processing is very, very easy to understand. Okay, in the remote sensing, you people know very well that Landsat satellite imagery or some of the MODIS data or some of the spot satellite imagery and then hyperspectral satellite imagery, we have the different band combinations. So in the different band combinations, according to your study, your need, if it is a geology person or remote sensing person, water resource person or forestry person, agricultural person, So depends upon your need, we have to perform various image transformation methodology. That all comes under the enhancement. So it's why we are doing this type of the things. Now, then only we can get the better interpretation, better feature extraction. So like that. So it is useful since many satellite imagery give the inadequate interpretation for image interpretation. In the raw imagery, we are not able to get that much of the information. If you are going for the various contrast enhancement and spatial enhancement, then you are going for transformation, then we will get better quality of that imagery, better object feature extraction of the satellite imagery. It is attempted after the image correction. After the image correction, that is in the first step of the image processing is image rectification, restoration. And next step, enhancement, various enhancement technique. Then only we are going for the transformation. So after attempting the various corrected and disordered satellite imagery only, in this step we have to perform. It may be temporarily or permanently. If temporarily or the permanently means in some of the features of that NV software. If you are working in NV software, then you people know very well. If the imagery, that is output of that imagery, if you don't want, if for the just an example, if you are performing the band ratioing for one band to another board, band 3 and band 4, now it will give the better results for the vegetation studies. If it is a band 2 and band 3, or some in places band 6 and then 5, then we are able to get the information about the geological applications. So according to that, if you want to work, if you get the better clarification of the clarification of the images, then you save it and permanently use. Otherwise, it will erode unpredictably. So these are all the various just types of the enhancement. In the enhancement, point operations and then local operations. Next one is the transformation. Actually, in that point operation, right, modification of the pixel values of one particular area. In that point operations, mostly we will perform in for the sixth line dropout and then noise and then salt and pepper effect. So these are all the various things. And then local operation, the cubic convolution, the 3 by 3 window, 9 by 9 window, that and all that in previous classes you people study. So thus this two all comes under the point operation, local operations are comes under various image processing. But in this section, with band ratioing and all those things are comes under the image transformation. In this one, enhancing the image by transforming the values of each pixels. Actually, transforming the value of each pixels of multi-band satellite imagery or multi-satellite bands. Okay, like that we are just transforming one imagery format, one imagery into another form. Then only we can get the better results. Normally, in the satellite imagery, the spectral and then contrast. So these are both are same. That is a contrast enhancement or the spectral enhancement. That is nothing but the amount of the difference between the average gray level of that object. That on average, actually all the satellite or the satellites while downloading the satellite, that imagery from the satellite, it will comes in analog format only. Here only we are converting the analog format to digital format. Okay, in the digital format, converting the analog to digital format, the satellite imagery should be in always should be in the various gray shades imagery. That means up to white and then the ranges in between white and then black, the various shades. So normally it will comes into the various gray level. So in that illumination of the gray level imagery, it can appears in the different washout areas. So the maximum, it will give the ratio of maximum intensity. That is the maximum DN value and then minimum DN value. So these are all the various categories. Actually, in that yesterday class we have that I also listened that yesterday class. In that class, actually that edge enhancement and then spatial enhancement. In the spatial enhancement, edge enhancement or comes under this type of the intensity based assessment. So in that ratio of the satellite imagery, larger the ratio, more easy it is to interpret it. You see here that in the convolution method, then contrast method, the band value of the minimum band value and then maximum band value. So if you are taking in one band ratios, the minimum value and then band value of your maximum and then minimum value, if you are ratioing, that means you are giving the ranges, it will give the exact features. That means that it will give the better results for that drainage path, line path, that imagery and all I will show in next coming slides. Actually, these are all the things. So why we are going for the various contrast other the spectral enhancement, the scene itself have the low contrast ratio. In the if you are performing in band 2 and band 3, it will give a better result for the water body feature extraction. So we can easily demarcate the water bodies. If you are doing for the band 3 and then band 5, I think, band 5 performance. In that one, we can easily demarcate the boundary of the water. That means the river, not only the river boundary, water throwing the particular river, not that part also we can easily demarcate. So in that case, demarcation of the drainage length and then streams and all those things are possible in band ratioing. You see here, this is one of the simple example for the contrast. This is a normal FCC satellite imagery without doing any type of the spectral structure. But after doing the various enhancement, you see here the difference between. So in this imagery, in the spectral enhancement, we can easily demarcate the features, the difference between this raw imagery and then spectral enhanced imagery. So here you see here the water body, that river path in blue color, river in blue color, but in that blue color, darker tone is there. Now, this is the waterway. This is one water stagnating area. This is one reservoir here. Here you see that road, and then these are all the forest area, and then you see here the streets. The two also we can easily demarcate. So for that purpose, to get the better clarity of the satellite imagery and to get the better interpretation features only, we are going for the various spectral enhancement and then transformation. After that enhancement, we are transferring into the one thing to another thing. You see, here the image transformation typically involve the manipulation of the multiple bands of data, whether from the single multispect satellite imagery, multispectral imagery, if it is a list 1 data to list 3 data, so like that, different single multispectral imagery, or otherwise the images occurred of the same area at different times, like that. If it is a 2010 band 4 and then 2020 band 4. So the simple example what I am telling now, normally for the Landsat satellite imagery, sixth band is for temperature study. If you are taking only the sixth band means sixth band for Landsat TM, and then for ETM plus band Landsat sixth band 1 and then sixth band 2. Two types of data are that. If you are working in that particular Landsat data, that will be in gray shades only. If you are performing the giving the gain and then bias value, then emissivity survey, emissivity and then reflectivity calculations. After that, we are performing in every satellite imagery. Then automatically we will get the satellite temperature data from particular zone. So, excuse me. But using the only the sixth band, we can easily retrieve all those information. So like that, transforming the image. If it is, if you want to study about the temperature variation for the decadal changes now, so 2000 Landsat sixth band you have to take, and then 2010 sixth band you have to take, and then 2020 sixth band data we have to do. We have to perform various emissivity and then resistivity and all those performance. Then it will give the output of the temperature. Excuse me. By dividing all those things, that is ratioing of the all imageries, or otherwise we have to go for performing for the change reduction, then we can easily assess how much the variations of the temperature, how much of the variations in the temperature, all those things we can easily retrieve. Either way, image transformation generates the new images from two or more sources, which highlight the particular features or properties of interest rather than the original input imagery. Actually, I showed now. Wait, I will in upcoming thing I will show you the details. That means I told now, if it is a NDVA, normalized differential vegetation index, or otherwise normal moisture index, and all those various indexing, we have to perform in the different types of the band ratios. NDVA also on top of the band ratio, and then normal moisture index, vegetation indices, or and then NDWI, normalized differential building index, I think, NDWI, I think. So that type of the index also comes under in the band ratio. So we have to dividing different band of different satellites or the same satellite sensors, then we will get the better feature outputs. But behind that thing one, the most common transform applied of the image data is pixel by pixel value. That is normally two bands, band 1 divided by band 2, or band 2 divided by band 3. Band 2 divided by band 3, it will give better results for that water body studies. And then Band 3 divided by band 4, it will give better results for that agricultural studies. So like that, depends upon the user or the person who is working on that one. So we will use. So very popular technique is commonly called as the band ratioing. This is a mathematic, that is algorithm what they are using for the band ratioing. That means the brightness value of the band location. Brightness value, you know very well, that is nothing but that is the pixel values. That is the reflectance value of each and every pixel. It will ratio one band's pixel value into another band pixel value. This is the algorithm. This is the algorithm mechanisms, how that mathematical algorithm, how it is working. Okay. Normally, it is possible to divide the digital numbers of one imagery band to another image band to get the different third imagery. In the third imagery, it will remove all the influences of the light and then shadow. For the shadow removal, band ratioing is also it gives very good result for the shadow removal. So it is also possible to calculate the certain indices like the vegetation indices and then geological indices and all those things. Band 4 and then band 5 in some places, band 3 and then band 5 combinations if you are working now, then you can easily demarcate the places where the nicest rocks are there and then feldspar rocks are there. That type of, even though for the Salem in Tamil Nadu, one particular area is there, that is a Salem area. That area is very good mining area. In that mining area, most of the satellite based imagery applications, they have the persons, that means the pioneers, will use for the band ratioing only. Then we can easily demarcate the granite, gneiss, and then feldspar and then limestone area. That will use very good results for the band ratioing. That's why we are giving the different combinations of the band ratioing. You see here, band ratioing is nothing but you just open the satellite imagery in that software, it will give different bands, and then in the software itself it will give the band ratioing, that by which band only we have to give the input and then output. You see here, band 3 divided by band 2, it will use the soils. Very good application for the soils. Band 4 and then 3 and 4 both will give the very good result for agricultural studies and then biomass studies, because it will use in NDVA. Most of the persons know very well about that NDVA. It will use a very good result for the density of the vegetation. If he knows the density of the vegetation, then it is very easy for us to do the biomass and then total biome cover and then ecology characteristics and all those things. And the next one is the band 7 and then band 5. Dividing between the band 7 and then band 5, then we will give very good for the clay minerals, rock alterations, and then band 5 divided by band 3 also, it will use very good result for the geological applications. These are all the rock features and available. It will easily demarcate the various spectral ranges. These are all the rocks. This is entirely different rock. So through the field visit and accuracy assessment, we can easily demarcate this much of the area is covered by this type of the rock like that. Okay, this is for the example of the NDVA. A commonly used, this is very commonly used vegetation indices, which uses the red and infrared bands of the electromagnetic spectrum. Normally, it will use very good results for the density of the vegetation. It helps the this is all the information. It is very helpful for extracting information about the vegetation analysis. And then healthy vegetation will use the more reflectance, more reflectance. That means in that healthy vegetation, it will use the high density, high reflectance value, and then near infrared to the red image ratios, it is also will give the very high reflectance values. So to quantify of the vegetation, this much of the vegetation, greenness, or this much of the biome cover is available. If any stress in between the vegetation, that's also it will give the very good results of the NDVA. So for the density of the vegetation or any stress means if any, if in Tamil Nadu and Andhra Pradesh, most of the southern India, we used to face one disease in rice crop. That is called okay, for the assessment of the rice blast, that NDVA will give very good results. And within 2 to 3 days, the rice blast is spread all over the maximum cover of that particular zone, any delta zones. So that and all, it will give very good result. This much of the area is affected by the rice blast disease or some other disease. Similarly, last year we did one work for that desert locust, impact of the desert locust that is fully affected by the Rajasthan and that stretch, that area stretch. So how much of the area is devastated by the desert locust? That too also we can assess. For in that assessment, we used NDV is one of the important methodology because it will give very good result for the density of the vegetation and its characteristics. Normally, you see, the albedo values of the dry grass is not, I think that NDVI, it will give the results of one band, one imagery, phosphor composite imagery of the thing one. In that one, the values in between that NDVI is -1 to +1. So in that -1 to +1, the ranges we have what we are doing, that is we are density slicing. Density slicing is another one method. It will use the results of the DN values into various classes. That means various class intervals. That nothing but that is the difference of the class intervals. Then class intervals based, it will use the categories. So if you are doing, after doing the NDVI, if you are doing the density slicing, automatically it will use some ranges. So in the ranges, we have to demarcate the levels. This is if it is a range, this is a green grass. It is a dry grass. It is a cropland with very good for good vegetation. If it is a forest and then water body, that too also. So in that one, in NDVI, the healthy vegetation gives more reflectance in the near infrared zones band as compared to the one. So in the spectral reflectance, the spectral enhancement, if the vegetation is under stress, the well will be typically lower. That stress is not nothing but the pest. It maybe comes under the pest or disease or any deficiency. That too, three categories are comes under stress only, vegetation stress only. That too also we can easily demarcate. Why we are going for the band ratioing or application of the band ratioing is undesirable effects on the recorded radiance, that means various illumination caused by the topography. That too also we can easily easily we can change, like that shadow removal and then noise removal. For that also we are using the band ratioing. Sometimes the difference between the band values from the identical surface materials are caused by the topographic slope and aspect. So the changes due to the slope and then aspect and then shadows and then seasonal changes. Seasonal changes means it's also comes under the cloud cover or snow cover, all those things. For removing all those things, that too also we are using various ratioing methodology. These conditions are that these are all the various conditions that is ample for the ability to the interpreter to correctly identify the surface material. So in order to correctly identify the surface materials, we are performing the band ratio. Yes. Ratioing transformation can be used to reduce the such effects of environmental conditions. You see here that same cover crop, the radiance value with the radiance at the shadow is only 50% of this area sunlight. How they are converting and they are changing the thing using the band ratios. These are all the uses and applications of band ratioing. Certain aspects of the shapes of the spectral reflectance curve of different earth cover problems, that too also we can got out by the band ratioing. In addition to the ratios, may provide the unique information not available in any single band. If for each and every band, that means each and every band ranges, it's having the capacity to take the photographs in the particular. If it is a third and fourth, vegetation will be good. If it is a sixth, then it will capture automatically the temperature. Based on the temperature, it will get the or give all the information. So if you are performing the band ratioing, it will give the unique information which is not available in any single band. If you are performing in the 3 by 2, then the water body is very easy to demarcate. So similarly, depends upon the persons. If the water resource person they are using now, then 3 by 2 that is very good result, and then 7 by 5 that is also very good result for geological. So depends upon the user. That means the persons those who are working in the image processing to get the feature extraction according to their need. We have to perform the band ratios and the band. We have to give the band combinations. And then ratio discriminates subtitle the spectral variations. These are all the things. That's a simple thing. You see here, these are all the various the electromagnetic spectrum wavelength and in micrometers. These are all the various ranges. It will give a very good results. You see here the clear water with phytoplankton, that too also available. Third and then two band. If you want to the clear cut band ratio in water body water path demarcation, then the 3 by 2 is very good results. Similar way for that 3 by 4 and then for that 5 and 7, all those things. You see here, this is the infrared of that infrared imagery. This is red imagery. You see here that this is the ratio of infrared and then red imagery. This is normal vegetation indices. You see here, here we cannot easily discriminate the vegetation parts. Here you see we cannot easily discriminate the um, that place where the water body is also available and then vegetation. Similar, the water body and then vegetation is having the similar reflectance value. Here you see the water water path. Here the land area and then ocean, that means river path, we cannot easily discriminate. But after performing the band ratioing, here you see these are all the vegetation, that means deep forest. Here that river path is river boundary is there. Here the water going path somewhere, and then you see here the vegetation characteristics, different types of the vegetation, that vegetation, that means different vegetation might be there. If you are performing with the first color composite, then you can easily demarcate it. These are all the various commonly used vegetation indices. One is the vegetation index or the ratio of vegetation index. This is normal thing. Next one is the normalized differential vegetation index, and then transformer index. Other than that one, soil moisture index also there, and all those things are there. Next important component after that band brochuring, another one important component is principal component analysis. Principal component analysis is nothing but this is a different bands of the multispectral satellite data are often highly correlated and this contain the similar information. Actually, this is the one of the best methodology while performing the agriculture, forest, water resources and many of the studies because then if you are performing the principal component analysis of the satellite imagery, it will give more and more amount of the covariances. If the covariances is very high, the greatest amount, that means the greatest amount of the variation is there, then it is very easy for us to extract the feature from the satellite imagery and it's from the original imagery, original satellite imagery. Normally, the graphical computation of this one is for the linear transformation of the variables. Actually, first in that behind the screen, actually one long calculation is there. That means the algorithm is there for the principal component analysis. That is algorithm come mainly by the statistical persons and then CSE person, computer science person. They will write the algorithm and then they will. But in our point of view, how we have to understand the principal component analysis. If you are performing the principal component analysis, we can get more and more number of the covariance. I will show you that PPT in that upcoming slides. Then only it is easy for you to understand how the results of the principal component analysis for that one. You see, and the translation of the coordination system. These are all the methodology. That is a correlation scatter plot of that PCA analysis, how that is correlating. You see, this is positive data, negative data. These are all the values what we are getting. You see here, this is Fosco composite of the imagery, the data and all those things using the density slice and then all those things. If you are performing, then we can be able to get this type of the values. And then you see here, this is the output of the principal component analysis. The data will be like that. If you are performing the principal components, we can easily demarcate different ranges, how it is presenting. Wait, I will show you. This is the principal component output imagery. The first component, it broadly stimulates the standard background. In the first, that means after performing the principal component analysis, this is the first PCA band 1 imagery. It will give the information like you see here, the streams and then drainage and then plateaus and then these are all the hilltop and then from the hilltop how the drainages and then slope will be there. And then these are all the river path. You see, this is the river path, and then here in that river, the water body, where the water body will be there. Here, that reservoir also we can easily demarcate. In that, here you see, here some structure will be there. Here also, and then places where the settlement. These are all the settlements. This is like that. Only the principal component band 1 will be like that. So in the band 1, we can able to get more variance. If you are getting more variance, then we can easily extract more number of the features. You see, this is for the principal component 2. If you want to exactly demarcate the water body, you see here the accuracy of the band 2. You see, exactly we can demarcate the water area. And then you see, this is the river reservoir boundary, how the reservoir boundary, and then path also, drainage path. we cannot be able to discriminate here one plateau is that, no, that and all you cannot easily able to identify. But in the principal component 2, and here you see the difference between the this area and then this area. This is the fully completely vegetation area. This is just a fallow land. Fallow land means just a cultivated land, or this season only they are not cultivated. So that is called as a fallow land. So this fallow land area. So that and all we can easily incorporate. It will give little covariance. This is the principal component analysis, third band imagery. In the third band imagery, water path and then soil characteristics, some of the agricultural feed, that area also we can. But in this imagery, we can get only the little covariance. If we are overlapping all those things, you see here, this is the color composite of the principal component analysis. In that, you see in the principal component analysis output data, we can almost demarcate most and most number of the features. You see here the plateaus also we identified, and then streams, and then water body, that means river path, and then water body, that river, and then water path, and then agricultural area. These are all the dark vegetation area, dark agricultural area. Here also just fallow lands, and then even though the road, and then here also one small road is going, so we can easily extract more number of the features and features in the principal component analysis. That's why most of the persons are going in the PCA analysis for the better feature extraction in digital image processing. Next important thing on is tassel cap information. You see here that name itself, it will use the better understanding the tassel cap. That means the thing what is covering the earth feature or the surface feature, that too also we can remove and then we can identify. For that also some algorithms also there, that is developed by Koth and Thomas algorithm for multispectral satellite data. Actually, based on the band sequential organization technique. Actually, in that different band types, you people might study about the band sequential method. Band interlude by visual, band interlude by line, band interlude by the sequential, band sequential method. So, in the band sequential organization technique, it produced the orthogonal transformation of the original 4-channel MSS data for to a new 4 dim spaces. It is called as a tassel cap due to its cap nature. It is mostly used for the agricultural purposes to assess the soil moisture and then soil condition, to assess some rocky structures. It will almost 50 to 60% it will give the better results, because if you are performing the tassel cap, it will remove that covering area, that means that canopy cover of the crops and all those things, and it will give better for the soil moisture, and then soil characteristics, and then water body, and then wetland, and then swampy land identification. So that type of the things. Actually, here you see that soil brightness. There are the 4 new axes of the tassel cap method. Is soil brightness index. It will use the soil brightness, depends upon the nature. Then next one is the green vegetation index. If you are performing, then it will use the, depends upon the canopy cover, it will use the green vegetation index. And then yellow stuff index for the stress area or infected area assessment. And non-such index, actually non-such index means automatically it will use the some of the mask or the masked area assessment. Actually in that mask area assessment, actually automatically it's not able to perform that methodology, but it will give some non-such index area. Almost in that tassel cap, soil brightness index and then soil vegetation index, it will give the better results. Okay. You see, this is the Kout and then Thomas developed the tassel cap measures. This is the various brightness, and it will use the, you see here the crop developed in the tassel cap brightness and then the greenness transformation, and then location of the land cover when plotted into the greenness. This is the methodology, and then output of the algorithm, how it is derived. But here you see that various moisture of the plants, that is wetland and then dry soil, or the concrete or the bad soil, that too also it will give the information. For that only we are performing the tassel cap methodology. And next important thing is image fusion. Image fusion is nothing but we have to fuse one satellite imagery or to another satellite imagery, or one satellite sensors imagery to another one satellite sensors imagery. So like that, we are fusioning, or we are merging the satellite imagery. That is also one of the important step in that image transformation methodology. Actually, most of the things is then the panchromatic mode of the satellite imagery. Then a panchromatic satellite imagery means that is a comes under black and white, and the resolution is very high. That means 1 meter resolution. If you are merging that panchromatic into multispectral satellite imagery, it will give the better output to interpret the building and then roads and then parcels of the agricultural land and all those things. Usually for the multispectral mode has a better spectral resolution than the panchromatic mode. That means the most of the satellite sensors such as the panchromatic mode has better spatial resolution than the multispectral. So to get the better thing, you have to combine the different spatial and then spectral resolution of the different sensor satellite imagery. It will give very good result. You see here, this is the panchromatic imagery of some hilly area which is going for the shifting cultivation, that means step cultivation. Here you see in the similar area, this is for multispectral satellite imagery. If you are doing the data merging or the data fusion, you see here in that multispectral, we can fusion imagery, we can easily demarcate that area, which area is covered, whether it is a tea plantation or crop paddy plantation, or these are all the areas just fallow land, just fallow land or just cultivated, just they keep as a fallow land like that. Or otherwise it is in a nursery. If it is a nursery state, that too also we can easily demarcate. These are all the things for that panchromatic other data fusion, advantages of data fusion. That means um, uh, panchromatic, that is blue, black, and yeah, various gray shades, and then multispectral. If you are merging to these things, we can get better interpretation of the satellite imagery. Similarly, you see here, this is icon of satellite imagery. This is for a area nearer to Chennai only. You see here, these are the panchromatic data. This is icon satellite data, ISPO data. If you are super merging these two things, you see the better results. Even though the coconut canopy also we can easily demarcate. So these are all another one type of the image transformation that is called as a image merging. This in that image fusion, band substitution, and next one is the numerical method, and then statistical method. Actually, in the statistical method comes under PCA only, that means principal component analysis. And next one is the color space transformation. Color space transformation is nothing but RGB to false color composite, and then transforming the high HS, that means intensity hue saturation transformation. Advantage of the aim and use of the image fusion is sharpening of the imagery. You see here that imagery, how that imagery will be. Normally in the panchromatic it will use sharpening imagery, but here you see in phosphor composite that coconut trees are how it should be, and then here also you see the parcels and then lands, different types of the parcels, and then it is covered by various plants and like that. But here you see we can get the better output of the image fusioning imagery. This is the more accurate. So similarly, the sharpening of the image, that is the main use of the image fusion, and it enhances a feature not visible either in the single data alone. If it is a black and white data, that is various gray shades imagery, then in some features we are not able to easily retrieve. But in that fusioning of that one gray square imagery into the MSS, then it is easy for us to discriminate the features. And reduction of the changes, change reduction also, it will give very good result of the various multi-temporal satellite data. And substitute of the missing information of one imagery with the signals from the another satellite imagery. If it is a same area, different season imagery, then it is easy for us to merge one area, that means the same area, different satellite or different sensor imagery, then we can get the missing information and reflects the, it will replace the defective data. This is up to that image enhancement. But another one important thing in this one is, sir, I will share another change reduction also I will share. Another one important topic in the image enhancement is change reduction. Change reduction in remote sensing and GIS is a method of understanding how a given area has changed between two or more time periods, whether it is the decadal or 20 years once data or seasonal data. So it will give better results how the changes has happened, in which method. If it is a crop cultivation aspect, any changes are there, or any geological or geomorphological changes, or pre-tsunami and then post-tsunami changes, or pre-cyclonic and post-cyclonic disaster, any disaster-based change reduction. All those things we can easily apply for the change reduction methods in image processing. It helps in many applications such as the land use land cover change reduction and rate of deforestation, and then what are all the possible zones for the afforestation. That too also we can easily demarcate. And then coastal changes. Coastal changes means nothing but that coastal line changes, whether this much of the erosion or accreditation changes, or otherwise that any coastal features like that coastal zone management regulations. What are the features comes under coastal zone regulations management, or beach changes, beach morphological changes. All those things we can easily do in by using the change reduction methodology. And next, urban based study in an urban sprawl, how the urban is sprawled, which direction the urban is sprawling, whether this depends upon the resources available in a particular area it is changing, or any other criteria is in that urban spot. So according to that we can easily develop the city, and then we can easily adopt uh, any methodology to improve the corporations and all those things. Normally the change reduction involves comparing changes between the aerial photographs taken over of the different time period that cover the exact same geographic area most of the time. So the change reduction is performing in same area, same month satellite imagery. If it is an agricultural based study in the same area, but different seasonal imagery. So like that we have to perform certain norms to do the change reduction methodology. Normally for that urban changes, how the urban is changing for the past 10 to 20 years, 30 years, 40 years like that. So that is one of the important thing. That's the urban sprawl is also coming under that one only, how it is changing. What are all the advanced methods we have to perform in that particular zone like that. Next one is the environmental change. Environmental change means if that area is comes under polluted area, how much the pollution is happened like that. So similarly, next one is the drought monitoring. Drought monitoring depends upon the water scarcity of the water, how that area is affected by drought. What type of the drought? Whether there is a meteorological drought or agricultural drought or any other some other drought. So like that, which type of the drought is happen in that particular age zone? That too also we have to perform the change reduction. Next one is the flood monitoring. During cyclone time, what are the zones? What are the zones for the affected by flood? That is flood prone area, less flood prone area like that. Various flood monitoring assessment also we can easily, and that depends upon the elevation, uh, elevation and then slope and then digital elevation model, we can easily perform the flood monitoring also. Next one is the coastal marine environments. Coastal marine environments, whether these areas are sea algal bloom studies, and then sea surface studies, surface temperature studies. So and then other applications such as the crop monitoring. Crop monitoring means the areas are comes under the horticultural crops like orchards. So there also we can easily demarcate this much of the areas are covered by coconut plantations or mango plantations or some other plantations. So this much of the area is completely devastated. So another one important thing on shifting cultivation, where the shifting cultivation is happen, whether we have to go for the afforestation. So the crop monitoring assessment. So these are all if the available water resources. So this is the crops. So like that, the decision support system for the spatial decision support system, and then resource information system that Indian government we are adopting they adopted the resource information system. For that type of the thing also the change reduction methodology is very very important. The land is land cover, forest and then vegetation stage, forest mortality, defoliation study, and then damage assessment. If any disasters happen, that time the damage assessment and then defoliation study that also we can thing. And then forest fire affected area, and then landscape change. If any earthquake or something is happened, no? So how the landscape is changed. So pre and then post disaster study, or pre and post changes study. For that purpose, the change reduction is very very important. Actually, it can be used to measure four different types of the changes. changes in the identity of the feature over a time. Identity of the feature over a time means identity. That means these all the areas are comes under the coastal erosional area, or if this is a coastal accretion area. If it is a coastal erosional area, what are all the control measures we have to take? Or it is the feature that is that identify the features. That means feature based study. Therefore, that one. And then changes of features location over a time. Features location means in the most of the forest peoples, that means the tribal peoples, they will keep on change their location of the cultivation aspects. In some places, they will deforest on particular location, and then they will do some cultivation aspect, and then they will keep as it is that area, and then they will shift to some other places to for the cultivation aspects. For settlement and all, they will keep in one particular places for the cultivation places. So like that, in the forest itself, some open space will be there. So we have to identify the open space where the forest peoples or forest tribals they move that cultivation aspect. There we can easily demarcate using the change reduction, and then we have to go for the afforestation method. And then change of the features shape over the time. Feature shape over the time. Now, some in coastal areas like the bay mouth or that river mouth, somebody it is called as the river mouth, in changes in the jetties, how the jetties are changed and then bay mouths are changed. If any disaster is happened, the complete geomorphology or the land features, how it is changed. So that type of the shape also we can, shape based change reduction also we can do. And then changes in feature size over the period. Feature size over the period, in that one best example is right now what they are doing now, how the water body is changed in the settlement. If any village settlement is there now, how the water body is changed for the past 20 to 30 years. If that the changes of the water bodies and then tanks and then rivers, whether that river, the particular area is completely occupied, some bites and settlements. So like that, feature wise size over time. That means that shrinkage of the islands and then shrinkage of the water bodies, that too also we can easily demarcate using the remote sensing method. Actually, the change reduction involves the use of multi-temporal data sets. Actually, using the multi-temporal data only. Multi-temporal means any year-based temporal data or 10 years once temporal data like that. Use the multi-temporal satellite data is very used to perform the change reduction of a particular area. If it is going for the agricultural based crop based study, now the season also we have to keep into the mind. If it is a comes under the Kharif season or Rabi season or summer season or winter season, then we have to take into the criteria in the same season next year imagery or 2 years imagery. That and then we have to take into the consideration while doing the change reduction. Ideally, it requires the same or similar sensor or similar resolution and then viewing geometry and then spectral band and then same radiometric resolution and the acquisition time of the data. If it is a morning 10 o'clock, if they are taking now, if that day, that means after the next season, next Rabi season or Kharif season, the same time and then same date, they has to take the, if these are all the things, if it is a clear cut in the change reduction, the accuracy will be very, very good in change reduction assessment. The method is independently classified and registered and then compare them. Independently classified means actually the classification, image classification and all tomorrow class I think they will teach you how we have to do the classification. But after performing the various enhancement technique, the tassel cap band ratioing, even though in the band ratioing imagery itself we can do the change reduction. Similarly, for the NDVI classification, NDVI indices, indices method, that is the one type of comes under band ratioing only. If you are performing the NDVI, in that NDVI also different time NDVI, 2 year NDVI or 3 year once the NDVI imagery which you are taking. Then if you are performing the change reduction, change reduction means that density of the vegetation, how it is changed. Or if that particular area is affected by the forest fire, immediately before fire, before the disaster, how that area will be. This much of the area is devastated, affected by the forest fire. So that type of the information also we can easily assess. And then classification of the combined multitemporal. Multitemporal is very, very most. And then principal component analysis of the combined multitemporal data sets. If you want to perform the principal component analysis for the season based, canopy based study or phenological based study, that will give very good results for the principal component analysis. And then image differencing. Here the subtracting is nothing but that is a band ratioing. Okay. That is also will give. And then subtracting and then dividing. Subtracting and then dividing, both are comes under band ratioing. You just think about the NDVI and then moisture index. First we have to subtract from NIR to red and then NIR plus red and then divide both the things. So that's all comes. So, and then chain reduction vector analysis. If it is working in image processing, NVR, AirDAS or GRAS or some other software, then directly we have to convert that to into the vector format, and then we will calculate this much of the area is covered by this one. So this is the changes happened because of this research or like that. And then delta transformation. Delta transformation also we can assess easily after that flood or any cyclone happened like that. An important thing one is the change reduction techniques is one is a visual analysis. Just by seeing and then we can easily tell this area is changed like that. Next one is the image differencing. Image differencing, it will use the accuracy level very high because it will use the information about the pixel by pixel data sets. Image ratioing will get the better feature extraction. For that purpose only we have to adopt for the image ratioing. And then post classification comparison. The classification method under tomorrow class R will teach, and after the classification, the field verification. After the classification, we have to go to the field verification. Then only we get the accuracy of that applications, various applications. Then we have to compare the post classification comparison, how we have to change further, and again we have whether we have to go for again the classification. And next one is the statistical analysis. Statistical analysis nothing but it will automatically the changes. This much of the area is changed into this one. This much of the wasteland is changed into this much of the afforested zone. This much of the barren land is changed into the forest agroforestry area. This much of the kharif season single crop area is converted to double crop area. So that type of the statistical information, and then productivity assessment, and then production assessment, vegetation production assessment, that is crop yield assessment, and all those things we can easily do by using the change reduction. If they are doing the crop cultivation assessment of one particular zone, that means 2000 and then 2002, if they are doing the 2 seasons, no? So within 2 years, how much of the productivity is variations? It is its cumulative index and then frequency, cumulative index, that is its mean, and then all those things, it will give the better results. Actually, for the example of the classification is based on that land cover vegetation, and then change reduction means land cover change, and then extraction of the physical quantity that I told now already, that Landsat 6th band will give the better results for the temperature based assessment and temperature based study. So automatically if you are performing the gain and bias assessment and then emissivity and survey, after survey, it will give the temperature value. And then in the temperature value, again, in the temperature value itself, we can easily identify this much of the temperature variations between the 2000 to 2010, 2010 to 2020, 20 to 22. Till date, we can easily extract the information of the physical quality. And then extraction of the indices after performing the complete indices. The turbidity index is also we can easily assess for the water body, how much the turbidity is accumulated, or before tsunami, or before cyclone, or after cyclone, how the turbidity is changed, like that. And identification of the specific features. The specific features mostly we are performing for the disaster-based assessment studies, like forest fire, flood, and then extraction of the lineament of the archaeological features. The lineament reduction of the archaeological features also we can easily demarcate using the thermal imaging scanners or sensors. Thermal imaging sensors, it can easily demarcate where the fractures are happened, or where the lineaments are happened in the temples or any archaeological source. That too also we can easily demarcate. You see, this is the change reduction procedure. This is one particular area, how it is changed. Different season. This is the use of multi-temporal data sets to discriminate the areas of land cover change between the date of imaging. You see how the land cover is changed. Similarly, you see here, this is 1994 satellite imagery and the 1996 satellite imagery. This is for just to see. And then if you are performing various classification, and then if you are performing various statistical, then it will automatically give this particular area is completely, this much of the agricultural area is converted into the settlement. You see, this area also comes under the settlements. So within 2 years, they get that settlement. And then here you see this is the mangrove vegetation. In 1986, how the mangroves will be there, was there, and then in 2002, how it improved, how much of the area is restored. So like that, we can get the information. Similarly, you see here that some coastal feature. You see the beaches, how it is changed. You see here the thinning of the spit beaches. You see here, this is the this much of the area is covered by the beaches and beach areas, but here you see the beach, how it is changed. So that too also we can easily assess. This is the Orissa area. You see here, this particular area, due to the beach erosion and all those things, this area is completely cultivated by the mangrove ecosystem to prevent the loss of the beaches. You see here the beach is completely reducing its level. That means the beach accreditation erosion is more. So in order to avoid the beach erosion or the beach cooling, they cultivated the mangrove. Similarly, this is for 2000 shoreline changes of 1986, 2001 and 2004. This is my old study only. That's why I'm showing. You see here how that areas are completely changed. This is for the 2004 tsunami, the worst affected because 2000. This is December 21 satellite imagery. You see here during tsunami, December 26th during tsunami. After tsunami, the completely that island is completely changed. This is the Trunkle Island of Andaman Nicobar Islands, one of the island in Andaman Nicobar. How that island is changed. So like that. Similarly for this Chennai, before tsunami and then after tsunami, how it will be like that. You see here that completely the bay mouth is completely opened. Similarly for the urban sprawl study, you see here the urban sprawl. This is the vector layer of the urban sprawl. This is derived from the directly from that image processing software to directly that is converted into the vector layer. You see how the urban is closed. Similarly, this is the temporal assessment of the land use land cover of urban heat island study of satellite imagery. You see in 2006, the satellite imagery, how it will be. This is the temperature data. We derived the surface temperature data using the Landsat 6 band. Now, how the temperature will be. Similarly, for 2010 satellite imagery, 17 satellite imagery, how the temperature ranges. This is, you see here, comparing to that one, you see here, this is for 2006 and then this is 2017 satellite imagery. The urban sprawl is also developed. Urban area is also developed. Similarly, for the temperature rises, you see here the temperature. And 41 is the minimum and the 46 in 2006, but in the Celsius in 2006, if it is, this is not the temperature in the temperature, that is a surface temperature. Okay, normally the satellite imagery of Landsat 6 it reduces the surface temperature. So difference between the surface temperature and atmospheric temperature is little variation will be there. Okay, similarly for the change reduction studies for the, this is also my work only, Uttarakhand change reduction. This is for one seasonal change reduction only. The same area, same places, how the glacier changes. This is also one project we got from seabed. So we performed this one, how the glacier changes for just one season only, 1 year only, 1 year change reduction. Similarly, this is for RGS software that is not relevant to the image processing. This is relevant to the GIS only. How the change reduction of the zinc concentration of the pre-monsoon and then post-monsoon area using the field visit only we have taken and then interpreted into the GIS. You see here similarly the lead for the pre-monsoon and then post-monsoon changes. These are all the methods for doing the change reduction, how we have to do. Normally for the goods change reduction research should be provided the following information. That area change, how much of the area is changed and then rate of change of the area. Next one is the spatial distribution of the changed type. How, in which way it is changed and then and its distribution, in which direction it is distributed like that. So these are all the important things. And next one is the change trajectories of the land cover types, how that land cover is changed. So in which way it is changed and what are all the things that is changed. And then accuracy assessment of the change reduction results is very, very important because in that accuracy results will give the strengthen your data. So this much about the change reduction. This is the results for the good change reduction. Thank you. Thank you, sir.
Thank you very much, ma'am,
Thank you, sir.
for
Any
your
query?
resourceful and enjoyable deliberations.
Yes, sir.
I'm
Thank you.
sure all the participants might have enjoyed your session.
Yes, sir. Thank you,
Yeah,
sir. If any queries
and
is there, yes, sir.
yeah, I'm going to ask. Dear
Yes,
participants, we are very lucky that we have a scientist as a resource person.
sir. Thank
And
you, sir.
when a scientist shares his her experience that are more practical, definitely that will be helpful to carry out our research also. So I request all of you kindly ask your queries, questions if you have. Yeah. Rajendra Parmar sir is all the participants are appreciating your session.
Yes, sir. Thank you,
Yeah.
sir. If
And
any
on behalf,
queries, yeah.
on behalf of all the participants and collaborating institutions, I also appreciate your session.
Thank you,
Ma'am,
sir.
I have one query on behalf of PG students from my department
Yes, sir.
that we are working on a project
Yes, sir.
and which will be the best satellite data
Yes, sir.
for river basin analysis. We don't have any financial assistance. We are looking for only free data set. So please suggest out of that only that if we use this data set, that will be helpful for the morphometric and change detection analysis.
Sir, actually for GLCF, Glovis GLCF, lot of satellite imagery is also available. To get the better results means hyperspectral sentinel data will give the better results. But in the most of the places that will be not available. If it is available for your area, that will be very nice, sir. Moreover, in the Bhuvan satellite, Bhuvan, our Indian ISRO site is there, na? There also lot of satellites they are giving for to download freely, sir. So that is very good for one. And GLCF, almost all the satellite imagery we are getting. And then for river basin and all those studies, no, then the high resolution data will be very good
Yeah, yeah.
to do
It is
for that.
necessary. We have downloaded the list 3 data and
Yes,
we
sir.
are working on that.
Yes, sir.
But I thought that if you suggest any more that we may get higher resolution data sets.
So Sentinel that is freely
Yeah,
available, that will be very good, sir.
yeah, we have downloaded, but we are not getting high resolution because it has multiple bands, and according to bands,
Uh,
the resolution is changing. And for our region, we are unable to get that Sentinel data.
then go for the available data. With the available data, you go for the data merging, sir. Then it will
Okay,
give
yeah,
the
yeah,
better
yeah,
results.
yeah,
Data
yeah, yeah.
merging or the data
Yes,
fusion
yes,
option.
yeah,
That
yeah.
will give very good result.
Thank you, ma'am. Thank
Yes,
you.
sir. Thank you, sir. Thank you, sir.
Dear participants, please ask your questions. I want to study the forest change detection and forest pattern finding. Hasib has, ma'am, please, you please,
Yeah. Sir, actually, the forest change reduction and for forest pattern finding, that too also we can easily demarcate using the Sentinel data. Right now, that is freely available, even though for USGS land, normal Landsat satellite imagery will give the better results for that one. How can I approach? I will send my mail ID, sir. I will send my mail ID. You just mail me. If time permits, can come to our research center, sir. We will assist you. Lot of things are in the forest change reduction. Yeah, surely we will support, sir. Actually, in our research center, we are allowing the students and other participants to do, other persons to do all those research things, sir. Any other questions, please, participants? But thank you all. Most of them will send message for the thank you message. Yeah, thank you. If the content is very very useful to you, then I'm very very happy, and then I'm very much thankful to you, sir, to giving the opportunity to work, and then thank all the department persons and the management, sir. Yeah, to show all those things. Thank you. I think no questions that sir.
Yes,
Okay, sir.
there are no questions, only appreciation is there. And it talks about your lecture.
Yeah, Purnima, yeah, sure. I would like to apply all important application in my research. Please help and suggest. Surely. Surely, no problems. At any time, you just send a mail to me. Otherwise, my details and all those things available in website itself. You just check, and then if you want to come to our department, then you come and then work. Here, lot of satellites data is also available, and then licensed software is also available. If you want it, just I sent already my email ID.
It is posted in chat box.
Yeah, yeah.
It is posted. Ma'am, shall we proceed ahead
Yes, sure, sir.
towards conclusion?
Yes, sir, sure, sir.
Thank you.
Thank you.
Dear participants, since last 1.5 hour, we are enjoying the session delivered by Dr. Mona ma'am. Ma'am, on behalf of Devruk Shikshan Prasarak Mandal's Atle Sapre Pitre College Devruk, Department of Geography and Internal Quality Assurance Cell, and all the collaborating institutions, because in this workshop various reputed institutions from India has collaborated, and on behalf of all the participants I extend my sincere thanks to you
Thank you, sir. Thank you very
and
much.
looking for future collaborations also.
Yes, sir, sure,
We
sir.
will be in collaboration.
Yes, sir.
Thank you for giving your valuable time and sharing your valuable thoughts with us. Thank you.
Thank you,
Thank
sir. Thank you very much, sir. Thank you,
thank
sir.
you. Thank
Yes, thank you, sir.
you.
And
Okay.
I'm also very much thankful to you, sir, especially to given the opportunity, and then management person and all the things. And then thank you very much, all the participants. Thank you, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Thank you.
Yes.